Hello, my friend, and welcome to the study. Today we're going to have lots of paper sounds and some meteorology as we go through some sailing meteor papers. I have some old books here, and we can look at some notes and questions about weather. And we will go over a sample paper from the RYA and look at some other information about reading the weather and meteorology in Great Britain. So lots of paper sounds to relax you today. So make yourself comfortable and we'll enjoy some meteorology. This is Reed's Weather Handbook for Sail and Power. You can see all of the things that are important to know when you're on the water. And there's quite a lot of it. Air currents, sea state, different local factors, how to read different charts, and the terms for weather report or the shipping forecast, all of which we've looked at in the study before. Let's look through some of these notes. There's some notes on the shipping forecast and Beaufort strength. I've got a little chart that I like to keep on board whenever I sail. And these are weather forecast terms that will be broadcast every day at noon and also in the shipping forecast daily. So for visibility, sea state, pressure change, synoptic movement, that's the isobars, and weather arrival. These you can also write in the ship's log. So for visibility, if you have fog, you know you have a visibility of less than 1,000 meters. Poor visibility, 1,000 meters to 2 miles. Moderate visibility, 2 to 5 miles. Good visibility, 5 miles plus. And for sea state, which is the surface of the water, smooth is a wave height of less than 0.5 of a meter. Slight, a wave height of 0.5 to 1.25 meters. Moderate sea state 1.25 meters to 2.5 meters. Rough gives us a wave height of 4 to 6 meters. Very rough 6 to 9 meters. Very high sea state 9 to 14 meters. Phenomenal sea state, a wave height of more than 14 meters. And our terms for barometric pressure change. The barometer steady, there's a change of less than 0.1 hectopascals in 3 hours. If it's changing slowly, the change will be less than 0.1 to 1.5 hectopascals in 3 hours. Rising or falling, you can expect a change of 1.5 to 3.5 hectopascals in 3 hours. The barometer changing quickly, a change of 3.6 to 6 hectopascals in 3 hours. Very rapid change is a change of more than 6 hectopascals in 3 hours. Changing now, it has changed direction in the last 3 hours. So for our barometric pressure, we work in units of 3 hours. The synoptic movement, we have slowly moving at less than 15 knots, steadily moving at 15 to 25 knots, rather quickly 25 to 35 knots, rapidly moving at 35 to 45 knots. In terms of weather arrival, when is the storm coming? When will the rain come? If it is imminent, it will be within the next 6 hours. Soon, within the next 6 to 12 hours. And later, after 12 hours. So these are the terms that will help you interpret the shipping forecast. Here we have the regions of the shipping forecast. Southeast Iceland, Faroes, Fair Isle, Viking. We'll stay in the North Sea there. Forties, Dogger, Forth, Cromarty, Tyne, Humber, German Bight, Thames, Dover, White, Portland, Plymouth, Lundy, Fastnet, Seoul, Irish Sea, Shannon, Rockall, Bailey, Hebrides, Malin, and of course Biscay, Fitzroy, and Trafalgar. Then we have our Beaufort scale. This is a description for land areas. Wind force 0. The description is calm. Less than 1 knot, less than 1 mile per hour, less than 1 kilometer per hour. Smoke rises vertically, so things you will notice on the land. 1. Light air. This is 1 to 3 knots. And the direction is shown by the smoke drift, but not by wind vanes. Force 2 is a light breeze, 4 to 6 knots, or 6 to 11 kilometers per hour. Wind is felt on the face, leaves rustle, and the wind vane is moved by the wind. Force 3, gentle breeze, 7 to 10 knots, or 8 to 12 miles per hour, 12 to 19 kilometers per hour. Leaves and small twigs in constant motion, light flags extended. So if you're racing, you'll see the flags on the pontoons, the racing hut being extended and fluttering. Force 4, my favorite wind to sail in for cruising. Moderate breeze, 11 to 16 knots, raises dust and loose paper, small branches move, and that's 20 to 28 miles per hour. Force 5, fresh breeze, time to reef the sail, 17 to 21 knots, 29 to 38 kilometers per hour. Small trees in leaf begin to sway. Crested wavelets form on inland waters. Force 6, strong breeze, 22 to 27 knots, 38 to 49 kilometers per hour, 25 to 31 miles per hour. Large branches in motion, whistling heard in telegraph wires, umbrellas used with difficulty. Force 7, near gale, 28 to 33 knots. Whole trees in motion, inconvenience felt when walking against the wind. Have you been out in wind that strong? Force 8, gale, 34 to 40 knots. Twigs break off trees, generally impedes progress. Force 9, strong gale, 41 to 47 knots, 75 to 88 kilometers per hour. Slight structural damage, chimney pots and slates removed. Force 10, storm, 48 to 55 knots, seldom experienced inland. Trees are uprooted, considerable structural damage. Force 11, violent storm, 56 to 63 knots, very rarely experienced, accompanied by widespread damage. Force 12, hurricane, 64 knots plus, devastation. And here you see a little chart I like to keep, as well as some of these references I like to keep on board. So we have the passage of a depression. It gives a cross-cut of what you've seen in the weather. The wind, direction, pressure, rain, visibility, and temperature expected. So you can more easily read the weather that you're seeing offshore. Here we have the west and the east, so we can tell the direction of these arrows, and a bit of a scale, 300 meters, 600 meters there. So our cold front means the cool air is going down, it's falling, and we have cumulus clouds in the sky. Wind comes in strong gusts. The pressure is rising, then steady. It's sunny, and there might be some showers. Equal sun and showers. The visibility is generally good, except when you're in the rain, and the temperature is cold. And here we have a cumulonimbus, the wind direction, veering sharply and then becomes steady. The pressure is rising quickly and then becomes steady. Right. So you're standing here and this is sort of going this way. The rain is heavy rain and thunder and possibly hail for a short stint, and then becomes light. The visibility is poor in the rain, and there might be fog. The temperature falls and then becomes warm. And as the depression passes, the warm air is going to go up into the warm sector. So these cumulus clouds have developed into a cumulonimbus, and then we're left with a few cumulus there, and what we call here fractostratus. It's a little high, wispy clouds, and these will climb with the warm air front. So what happens between this depression and the beginning of the warm sector? The wind veers and the pressure is steady. There's a light drizzle. Visibility is generally poor. There's a little bit of fog there. And the temperature is warm. The cold and the warm is quite relative. And then as the warm front passes, the wind is backing and increasing in speed. The pressure is falling as the warm air rises. The rain becomes heavier and prolonged as the clouds rise. Visibility deteriorates and the temperature rises. And we'll look a little bit more at those. Let's look at some of the notes. We've done some of these before. The passage of a depression. And that's what we just looked at there. The stratus clouds becoming cirrus. The nimbus. The warm front approaches, passes. The warm sector and the cold front passing. And when we say veering and backing, we're talking about the wind direction. Veering is going to the right in the northern hemisphere. the west. And here we have different kinds of clouds. Stratus clouds, they're sort of layered clouds. If there are lots of them, it can make a very grey, gloomy day. They're a little bit fluffy and a little bit low. Cumulus clouds, lumpy, heaped, fluffy. Nimbus is a big, towering rain cloud. Cirrus are the high, wispy clouds, high in the atmosphere. And altus clouds are between cirrus and stratus, sort of mid-level clouds. Another clue we can have about the passage of fronts. In the beginning of a low pressure system, the wind is backing, and that's here in the northern hemisphere, chiefly in Britain and Europe, and when the wind veers, the cold front has passed. This is an interesting map. 6 air masses that affect the British Isles. From the north, the Arctic maritime. Wet, cold air brings snow in winter. Polar maritime. Showery, cold weather. Returning polar maritime from Greenland and the Arctic via the North Atlantic. Moist, mild, unstable air, rain and showers. These are the ones we get quite frequently, or most of the time in southern Britain, the tropical maritime from the Atlantic. Warm, moist air, bringing cloud, rain and mild weather. Occasionally we can get this polar continental from Eastern Europe and Russia. Cold, wet or dry. Moisture content depends on the length of the sea track. And tropical continental from North Africa. This comes over the Mediterranean surprisingly fast. It brings hot, dry air and weather in the summer. And here we have wind speed and direction. And about clouds, the leading edge is a warm front approaching. If you see a string of clouds, geostrophic, distance between isobars. And here we have again the passage of the front. And we'll look at some isobars, I think. Here's another RYA question. This is a typical exam question. In the western approaches to the channel, what wind speed and direction would you expect? So we're in position A, there's position B. So here we have our isobars, that's pressure. And we take a ruler and measure between the isobars. And here it gives us speed in knots. So we know here at A we're about, we'll say 50 degrees north, and we've got, let's say, about 7 millimeters between isobars. I mean, you can use millimeters, you can use croutons, whatever your scale is. We just want to get these numbers. So we've got 50 north and about 7. It's around about 25 knots of wind. And position B off the northwest coast of Scotland. And you can see this low pressure here with the isobars very close together as it comes over. We can see the weather moving that way. The system's moving that way, but the wind will be different directions, coming from different directions. So here you can see it's a northerly wind. Let's look at the isobars. That's at 60 degrees north, about 2 millimeters. And that looks to be about 80 knots of wind. It's very high winds there. And there we have radar, so we won't go into that. And there's another synoptic chart there. So we've done some of these before in the study and looked at some weather patterns. I'll put a link there if you want to see more of it. This looks to be in a little exam paper. I think we should have a look at that and see how we do. And there's the exam paper. So we have questions 1 through 14 there, and is that this one? This is another exam paper, isn't it? So a different one. Let's go through and see how we do. Which of the following best describes the characteristics of tropical maritime air? Well, to answer that, we'll have a look at our little chart. There's tropical maritime from the Atlantic. Warm air, moist air brings cloud, rain, and mild weather. So we would say warm, moist air that has passed over a warm sea. Question 2. How does the temperature of air influence its capacity to hold moisture? Well, we know that our warm front that we saw before brings rain because the clouds are going up with the warm air. So the capacity of air to hold moisture is increased as the temperature increases. We can see that as the warm front comes, we get fog. And as the temperature increases, we have very moist air. So the capacity to hold moisture in the air increases as the temperature increases. And as it decreases, we get more rain and fog. Number 3. What type of cloud is most likely to be seen within an unstable air mass? And there is our instability, our region of instability there. And that is a cumulus there. We have cumulus on both sides of that depression. So cumulus will be the right answer there. Now we have some vague synoptic charts in this question. Using the weather maps below, estimate the likely wind strength, light, moderate, or strong, and the direction that could be expected at the marked positions. So for this one, we are between two low pressure or depressions, which means we are there, right? And our wind will be quite variable because we've got several fronts coming together. So light wind and probably variable wind direction until one of these comes in. And B, here we have high pressure and very far apart isobars. So as the high pressure moves, we've got a northwest wind and the isobars are far away, so we have fairly light wind. And that's our high pressure, which is here. For C, there's low pressure over Spain, and the isobars are a little closer together. And we are right here on the coast of Africa. So we have probably here a southerly, southeasterly wind, and it won't be moderate, it will be strong because we have isobars a little closer together and it's moving towards the low pressure. Here, still on the coast of Africa, between a high and a low system, which means because the high is over here and the fronts are meeting, we're going to have a northwesterly wind, and it's going to be quite strong coming from that direction. So isobars will help you answer these questions, knowing whether the front is high or low. Number 5. Which of the following changes in barometric pressure would you expect to indicate strong winds? Well, we know from our chart, our pressure change and our hectopascals here in millibars, very conveniently, which happens, so we have to know both, but we can translate. So we can see that pressure change happens quickly, very rapidly, if there's a big change in the past 3 hours. So a fall of 3 millibars in the past 3 hours, a rise of 8 in the past 3 hours, a fall of 8 in the past 3 hours. Well, the key here is the change. It doesn't matter if there's a rise or a fall, but it's how quickly the change is happening. In A, it's only 3 millibars in 3 hours, which is not a quick change. So B and C would be correct. A rise or fall of 8 millibars in the past 3 hours will indicate strong winds. And here we have a question: describe the conditions under which a sea breeze is likely to occur. Here we've had a little diagram of sea breezes. this in our book, our little book. I'll get the little book. The sea breeze front. And then we have a string of clouds near the shore. The sea breeze sets in. The cool, moist air from over the sea meets warm, drier air over the land in what is sometimes called a sea breeze front. The convergence of air makes the air rise, forming cloud as a result. These processes are shown on the next page as the descent of the air over the sea causes warming and makes the clouds dissipate. It's these ones as well. So the dry air from the land meets the cool, moist air of the sea. High pressure at 100 meters creates an outflow from the land, and increased pressure over the sea and reduced pressure over land gives the sea breeze. And here we have our hectopascals, which is still on most barometers, non-digital, so analog barometers. So back to our question. Describe the conditions under which a sea breeze is likely to occur. A sea breeze is likely to occur in fair weather with a light offshore wind. The air over the land rises as the land heats up, causing the surface pressure to lower. Helped by an offshore wind, the ascending air is carried offshore where it cools and descends. The cooler, denser air over the sea is drawn towards the lower pressure over the land, and a sea breeze circulation develops. Let's go to our next page. Question 7. Where would you be most likely to encounter katabatic winds? Katabatic winds come off mountainous shores. A katabatic wind is a land breeze. Cooling over the land at night leads to higher pressure than over the sea, and therefore a flow from land to sea. However, the effect is usually less well marked, and land breezes are generally lighter than sea breezes. The effects can be enhanced by the air being channeled by river valleys, and even more so by the steep sides of the Scottish lochs and Norwegian fjords. These katabatic winds, as they are called, can be strong up to gale force in such areas, and particularly around the Greek islands, the Adriatic, and the Aegean. So our answer for question 7 is in the vicinity of steep mountainous coast. Question 8. Describe the conditions under which the following are likely to occur. We have land fog and sea fog. Let's have a look again at our reads. If a warm front is passed, you'll be in the warm sector, between the warm and cold fronts. What happens then will depend on how far you are from the low pressure center and how warm the air is relative to the sea temperature. Sea fog can be shallow with clear air on coastal hilltops and cliffs. That happens a lot near the Isle of Wight. At other times, it may lift to form hill fog with poor visibility, not necessarily down to fog limits at sea level. Be prepared for a low featureless cloud, perhaps with drizzle. Poor visibility. Near the coast there may be hill fog and steady, not usually very strong winds. So, our answer to number 8 is that land and radiation fog often occurs during settled weather, and that is in the autumn and winter. On a clear night, the land cools down quickly, which in turn reduces the temperature of the air above it. When the air is cooled below its capacity to hold moisture, as vapor, the moisture condenses to form fog. And a sea or advection fog is most common in late winter and early spring, when the sea is at its coldest. When warm, moist air blows over a cold sea, the sea cools, and the air below it reduces its capacity to hold moisture as vapor, leading to reduced visibility and fog. Question 9. If you were running before a southerly gale on the edge of a depression, would the low be to the west or the east of the vessel in the northern hemisphere? Well, we have Bayes-Ballett's law, which we saw in here, that states that the Coriolis effect caused by the turning of the earth has a significant impact on the sea breeze. We are accustomed to seeing this on a large scale with high and low pressure areas in synoptic charts, but it also occurs with local sea breezes. In the absence of other effects, the classical sea breeze will set in directly on shore, but will then veer in that way. When it's well established, it will blow more nearly along the coast. This classical textbook sea breeze is most likely to occur along a coastline with no significant headlands and bays. Or, say, Biscay, for example, with France's very straight coastline. On a typical sea breeze day, the sea breeze will start around mid-morning with a light onshore wind. Over the next 2 to 3 hours, it will veer and increase in strength. By early afternoon, it will be nearly parallel to the coast. On the eastern coast of Sardinia, shown here, and other Mediterranean coasts, the sea breeze sets in at about 10 o'clock local time and can easily reach force 7 by 1 o'clock. So Bayes-Ballett's law means that in the northern hemisphere, you have your back to the wind, the low pressure system will be on your left-hand side. This places the low to the west of the vessel. So, if our back is to the wind, we look to the left for the low, to the west of the vessel, from a southerly gale. Number 10. When approaching a windward coast, is the wind likely to back or severe in the northern hemisphere? Well, we just talked about the sea breezes along the coast, and here the wind is backed to a greater extent over the land than the sea in the northern hemisphere. If the wind is blowing off the land, the tendency will be for it to back as the coast is approached. And this is useful for offshore racing. What word is used to forecast visibility of less than 1,000 meters? Well, we have our chart here. Do you remember? Visibility of less than 1,000 meters indicates fog. You're doing quite well. Number 12. If the word imminent was used in a gale warning, how quickly would you expect it to arrive? Remember our weather arrival terms are 6-hour increments. Something that's imminent will arrive within the next 6 hours. And now we have a question to describe how a cold front occlusion occurs and the typical weather to be expected as it passes. Let's go back to our reads and look at some diagrams. Occluded fronts. If the cold front has caught up with the warm one, the system is said to be occluded. So we have a synoptic chart. No. What you will see is something like this, where the two fronts have caught up with each other, and the warm and the cold front is marked, and that's the occluded front. The system is said to be occluded. This transition from the pre-warm front to the post-cold front conditions will take place with no warm sector. If the occlusion process has just started, the fronts will still be vigorous, and the occlusion is likely to be marked by heavy rain. Thunder and lightning will always be a possibility, especially in the late summer and autumn. If the occlusion process is well advanced, the system will be weakening and the front less vigorous. And here we have this convection behind an occluded front, and there are the British Isles there and the coast of France. Having lost its supply of warm air, the low will deepen no further. Friction at the surface will slow the winds down. Pressure in the middle will start to rise, and the low is said to be filling. The satellite image here shows an occlusion crossing the British Isles with apparent low to the northwest. The convective activity in the cold air behind the front is clearly illustrated, as is the swirl of cloud around the low center. By this stage, the high-level vortex will have formed, and the cyclonic circulation will have extended right through the atmosphere. Convective activity is clearly random. Individual clouds are a few tens of kilometers across, but they're larger groups of cloud, some 100 to 300 kilometers in size. These larger areas might have been indicated on a synoptic chart as a trough. Question 14. Use the weather maps provided to answer the following questions. Here you can see the British Isles there, France, and the coast of Spain, and Iceland in the upper left, we have a few systems there, our occluded front, and very close isobars there, the warm front and cold front catching up. So you can see how this system has moved from west to east and what has happened. What type of weather system passes over the UK during Monday, Tuesday, and Wednesday? Here we have a vigorous frontal depression. Coming across like that. Describe the weather. Precipitation, wind strength, direction, and visibility to be expected along the English Channel on Tuesday at 12 o'clock. Channel is there. We have one front catching up to another. So what we can see is precipitation, mainly drizzle and wind, which will be here as our cold front catches up to the warm front. Which coastline of the Irish Sea is a lee shore on Tuesday? And there's Ireland and the Irish Sea. You can see those isobars very close. The eastern side, or the British coast, the English and Scottish coast of the Irish Sea, and the Welsh coast as well, we can't forget Wales, are on the lee shore, the leeward side of this front. Where is the cyclonic area of the system on Wednesday? Cyclonic area is centered over the sea area of Fisher. Remember our shipping forecast areas, and this area is Fisher. So when we hear our shipping forecast and we have a cyclonic system over Fisher, we know it'll be south of the coast of Norway. And where would you be most likely to find heavy showers on Wednesday? Along the south coast of England or the north coast of France. So as this cold front comes, where are we going to have the most showers? As the cold front passes into northern France, heavy showers are most likely along the north coast here, Brittany and Normandy. Well done. And here we have the Monday in close-up. And I think we had the Tuesday back here, didn't we? This is the Wednesday one. The cyclonic, and there is Fisher and the coast of Norway. And we have a little bit better view of the isobars there. And there's our Monday one, with the cold front catching up to the warm front, and the coast of Brittany there. And there, my friend, is a meteorology paper for sailing on coastal waters. I hope you're nice and relaxed, and maybe asleep, and having beautiful dreams, calm seas, Be good to yourself, my friend. Be kind to others. And be extraordinary.